work on what makes a relation a function. Okay, that's a very special relation. Are all over the place, but a function is a very special type of relation. We're also going to work with a domain and range, and then working with just the beginnings of writing things into function notation. A relation is a set of inputs and outputs. All right, so you can see a relation in a lot of different ways. So let's say I go 1, 2, 3, A, B, C. All right, so this is a mapping of a relation. We have one side here. The left side is typically called the domain, and the right side is called the range. So that's one way you can see this. Another way you can see this is just a simple XY table. 1, 2, 3, 4, 5, 6, 7, 8. Again, the domain will be the X and the range will be the Y. And then the last way that you'll see this is as an ordered pair. Okay, so those are three different ways that you'll see this. Now, this particular one, what I have right here is actually I have different types of relations here. All right, they're all three relations. This particular one, the very first one that I did, that is definitely just a relation. There is something special about that that makes it just a relation. The other two are both functions. And what makes a function, a relation, a function, is if you notice, every x value of these two has a different, and only that x value goes to that particular one. So, like if I were to add a couple x values to either one of these two things, if I were to add 1, 6 now, or let's see here, 1, 6, or let's go 5, 8. Okay, 1, 6 is a bad choice because the 1 goes to both 5 and it would go to 6. So let me cross that one off. But 5, 8 will work because notice every x goes to a y value. Now, I notice that these two both go to 8. That's fine. What can't happen is on this side, this number 1, it goes to both a and b. That makes it not a function. It makes it just a relation. All right, so quite honestly, what I do to check to see is I look to see, is every x going to just one y? As soon as I see 2 coming out of here, going to 2 different ones, I know that this is just a relation. If you notice with this ordered pairs that I have, the 1 goes to 2, 3 to 4, 5, 6, 7 to 8. That one works just fine. And again, I could add 8 going to 8, and that would work. Okay? It's only when 1 goes to 8. So now the 1 goes to both the 2 and the 8. That makes it not fair. That doesn't work there. All right, now, domain. Domain is the x coordinate, the range is the y coordinate. Okay, so that's what we're looking at for this. And what is domain and range? Well, that's going to be asked often. And as a matter of fact, here it is with this one. What is the domain? So as I look at this, the domain for this particular graph, well, the domain is a set, so I put set notation. And I'm going to list every domain value. So I have an x-coordinate of -2, an x-coordinate of 0, an x-coordinate of 2, and an x-coordinate of 3. So that's the domain of this one. Now, what's the range? Okay, now the range are all the y values. All right, now in this particular case, this is what we call a discrete graph. It has each individual dot. It's not a continuous graph. A continuous graph looks like a line or a shape that continues. Basically, a continuous graph, when I put the point down and then when I let go of it, that makes it a continuous graph. I can do that all the way through here. For this one, I have to put the point down here, lift it up, and put the point down here. That makes this discrete. So now, talking about the range of this one. The range of this one is up 4, range -1. The range of this is 3. Now, the 3 goes up 4. Well, I already have 4 listed, so I only have to list it once. Now, the question was, is this relation a function? Does every x value have its own particular, does it double up? Does -2 go to 2 different values? Does 2 go to 2 different values? Well, every number of the domain goes to one particular y value. So every goes to one particular range value. So this is a function. Okay, this would work. I want to continue talking about the domain range here. Now, on this one, this is a continuous graph. If you notice, it doesn't stop. Okay, so now the domain of this is, how wide is it? So I would go domain equals. Well, in this particular case, can you list every single number that it can be? I mean, I know all the way over here to -3, but then if I think about every x value all the way through, I can get them all the way over here, and it goes up to here. So it's every number between -3 and 3. The way that I write that is, the smallest number I put in first is less than or equal to x. Remember, x is the domain, so that's what we're worried about. Is less than or equal to 3. So that, so that is saying every x between -3 and 3. Now the range is going to be similar to this, except for this time we're looking for how tall it is. Well, this is a continuous graph, so there's going to be a whole bunch of them. Well, the shortest it is -2, and the tallest it is 1, 2, 3, 4. Now it's every value between there, and I can't list every single value. So I'm going to use an inequality again. So it goes from -2, and these are the y's, to 4. Well, less than or equal to, less than or equal to. A couple different hints about this so that it makes it a little bit easier. Notice the variable in the range is always y, and the domain is always x. The inequalities are always less than or equal to. And I always go smallest to biggest every single time. Now, I use inequalities when we're talking about a continuous graph. If it's a discrete graph where I put my dots down, then I'll have a different type of answer. Now, the question that I also like to ask about this one is this particular domain relation a function? Okay, so now if you think about this one, every x value, so if I pick an x value right here at 0, does it have just one y value? Well, remember, in this case, 0 will go to -2, but then again, 0 also go to 1, 2, 3, 4. So since this one has 2, this is just a relation and not a function. Okay, and we're going to continue to try to differentiate between those two. A function is a relation which each input has exactly, it's a one well-behaved. Well, I don't know what that means. So if I look at this one right here, see how 6 goes to 6, 4 goes to 3, 3 goes to 1, but 2 goes to 2 different values. Think about it this way. If you and another person, well, if you are working at some place and the first week you work 4 hours and you get paid 20, let's say you get paid $40. The next week you work 4 hours and you get paid $25. Well, if you work 4 hours, you should get paid the same amount no matter which week. So as soon as it gives you a different number, that tells me that this is not a function, this is a relation. So this is 2 hours work, you get -3 or 3. This one is a relation. And again, the quick and easy, I look down through here and I say, hey, there's 2 here, going to 2 different ones? No. This one, all right? Now, -7, 9, 14, 7. So in this case, does the x even repeat? And the answer is simply no. Well, this is a function. All right, so what I'm looking for is, I'm looking for an x that repeats. If I were to write this out, I'd have a 2 here, that'd be another one. So if it was in an ordered pair form, there'd be two x coordinates of 2. One going to -3, one going to 3, and that would be no. This one, -7, 9, 14, 7. They all are different, that works. Now notice, this one and this one both go to the same value. That's fine. And that's fine. You can do that, but you cannot have two x's going to the same place. Now, what about this one? Is this one going to be a function or relation? So I think the easiest place to look is at the 0. Well, I will go down here and I will go down there. So this is a relation. And, hey, what's the domain of this? Well, I don't know. Sorry, I don't have numbers there, so I can't tell. But the domain of this would be an inequality. And the range would also be an inequality in this case, because this is a continuous graph. Now let's look at the next one. Is this relation a function? Well, what I'm looking for is two of them that are on top of each other. And this one misses. This is a function. And then the last one that we have here is this one. All right, so is there an x value that shows up and has two different y values? This one doesn't. This is a function as well. This particular one, if I was going to domain and the range, this would be an inequality. It's a continuous graph. Now the middle B, this is discrete graph, so the domain would be each individual number. And the range would be each individual y. Okay? Just want to be able to get that done quick and easy. Now, there is a simple test to see if the graph of a function is a relation or if it's a function. Okay, it's simple. It's called the vertical line test. And it is exactly what it says. What you have to do is you have to draw a vertical line straight up and down and see if it touches that particular graph twice. That one touches it twice, that's a relation. This one, if I were to draw a line through each one of these, there isn't another dot on it. So this is a function. Here, if I were to put any particular vertical line, it only hit it once, that's a function. That's an example of the vertical line test. It's not a very complicated test. Now, the last thing that we're going to cover is how to change something from an equation to function notation. And honestly, just a very beginning understanding of this is all that I do is I change it from y equals to f of x equals 3x minus 2. So all I did is I changed the y to f of x. Now what this means, the function named f using the independent variable x is equal to 3x minus 2. That's all it's asking us to do. This is just the name. This is just the variable in the problem. That's all that it is. All right, so now if I look at this one, let's call this one g of x. I changed the name to g this time. It still uses the variable x is equal to negative 2x plus 5. Okay, that's all we're going to do there. Not much that we have to worry about. Now, what happens if they say, hey, let's take g of x. What's g of x when x equals 2? Okay, now what I do for this is it's asking me, really all it's asking me to do is put 2 in for x and then evaluate. So I write it as the function g with 2 in for x is equal to negative 2, and now I put the 2 every place I see the x. So this is negative 4 plus 5. This is just 1. Let's say here, I want to know what it is. Hey, let's say x is negative 3. So f of negative 3 is equal to 3 times negative 3 minus 2. Negative 9 minus 2, negative 11. Here we go. Okay, just about done with this. And here's the two examples of this. Oh my gosh, they changed the same one. That's no problem at all. And here's your assignment. Okay, please make sure you get this done. This is going to be